Okay, so we're taking a look at angle pair relationships. These are three relationships that you would have been introduced to last year, but you may not remember, and it's just good to review a little bit. So the first one we're going to take a look at is going to look something along these lines, and you may already be guessing what it's called. And anytime they form that straight line, they're what's called supplementary or a linear pair. You can hear either one of those names would be totally fine. And in essence, all it's saying is that the two angles together add up to a straight line or 180 degrees. We won't just have supplementary, but we could also have a figure like this, in which case we would say that the angle pair is complementary and the two angles add up to 90 degrees. Now, one point that I want to clarify right here, you'll notice I drew the box in for the right angle. Just because it looks like it's a right angle, you can't assume. So you want to make sure that it is 90 degrees. You either need to be told it was 90 degrees, or you need to be able to view a box in the corner right there. Moving right along, we could also have the following picture, in which case we're going to end up with an angle relationship called vertical angles. And in this case, what we have is the following. If you have two lines that intersect, opposite angles are equal or congruent. So I have both angle 1 and angle 3 are equal to each other, and both angle 2 and angle 4 are equal to each other. As we get in the habit of solving problems, I highly recommend identifying which angle pair you're using and not just jumping straight to the pattern, so that you can maintain good habits. Okay? So, first example we're going to take a look at is this one right here. We're told to find x. And so when I look at this problem, I can identify that these two angles are opposite each other, and they are in fact vertical angles, which means I can set these two pieces equal to each other. So I'm going to say 3x plus 5 is equal to 5x minus 27. And then it just becomes a process of getting x alone. So I'm going to move the x's over to this side because I like to keep x positive. So I'm going to go minus 3x. I get 5 is equal to 2x minus 27. I now need to move the numbers to the other side, so I'm going to add 27 to both sides. And I get 32 is equal to 2x. And then lastly, to get x alone, I divide both sides by 2. And I end up with x is equal to 16. I used the angle relationship of vertical angles to set up my equation, and then I was able to get x alone, and I solved and got x is equal to 16. Okay? Gonna take a look at one more real quick. We've got this one right here. We're told to find angle ABC. It's very important, so we're going to come back to that. When I look at my figure, I have these two angles that are right next to each other, and they form a straight line. So as a reminder, that would be supplementary. That was the first pair we saw. Two angles form a straight line, supplementary, which means they add to 180. So I'm going to take my two angles, and I'm going to put 2x plus 4x plus 150 is equal to 180 degrees. Go ahead and combine like terms, and I get 6x plus 150 equals 180. Subtract the 150 from both sides, and I have 6x is equal to 30. And then divide both sides by 6, and I got x equals 5. So I found x, right? I'm happy, I'm done, I got what I wanted. Almost. Always make sure you find what they ask for. It's really easy to find x and think you're done, box it and move on. But in this particular case, they didn't ask for x. They asked for angle ABC. So how do I go back to my figure and find ABC? I have to take x is 5 and plug it back in. So I know that angle ABC is equal to 4x plus 150. I'm going to take angle 5 and plug it on in. So I'm going to have 4 times 5 plus 150. I get 20 plus 150, and I get that angle ABC is equal to 170 degrees. Okay? So I didn't just stop when I found X, but I made sure to find what they asked for.